Hi guys, and welcome to another video. In today's video lesson, we are going to be looking at Euclidean geometry, proving the tan chord theorem. Now the question in the exams will look as follows. It says, use sketch in the special answer book to provide the theorem which states that BAT equals to C. BAT is the angle between the tangent and the chord AB. The tangent is PAT. We want to prove that it's equal to this angle here, the angle in the alternate segment, which is subtended by chord AB. Now, in all proofs, what you have to learn is the construction, number one, and number two, the reasons that are used in the theorem. For example, this is what we are going to be doing. We're going to be constructing a diameter there. So we're going to have diameter AO, and let's call this point K. The next thing that we are going to be constructing is CK, which is our chord. So we just join points C and K. Then we are going to be calling this angle here, which is KCB, 1, and we're going to be calling this angle here BCA, 2. So that's 1, 2. And then again, we're going to be calling this angle 1, and then we're calling it 2. So once again, remember your construction is the diameter AOK, and then you just join these 2 points here to form a chord. So let's write that down. Construction, join AOK and CK. Alright, we can also say join diameter AOK. But as you can see, it goes through the center O, therefore AK is a diameter. Now why do we do that construction? The reason we do that construction is because we want angle in semicircle. So we want that angle there to be 90 degrees. Let's just write that a little bit neater. And also, what do we have here? We have a tangent which is perpendicular to, there's a tangent PAT is perpendicular to the radius here. So that's also equals to 90 degrees. Okay, so that's basically the proof in a nutshell. We're going to be using angle in semicircle as reasons, which is 90 degrees, and tangent perpendicular to radius. Right, and one more reason we're going to be using is angles in the same segment. And there's it here. You can see that angle C1, right, is subtended here by this arc KB. C1 is going to equal to A1, angles in the same segment. So that's basically the tan chord proof in a nutshell. So once again, make sure you do the construction AOK. You're going to join AOK, the diameter. You're going to join chord CK. You're going to call this angle C1, C2, A1, A2. The reasons that you are going to use is angle in semicircle. You're going to use tangent perpendicular to radius, and you're going to use angles in the same segment. So let's write our proof down. So now we'll say C1 plus C2 is equal to 90 degrees. The reason there is angle in semicircle. Then we're going to say A1 plus A2 is equal to 90 degrees. That is because the tangent is perpendicular to the radius. Then we're going to say that C1 is equal to A1, angles in the same segment. C1 equals to A1. C1 equals to A1, angles in same segment. Therefore, what can we conclude? Therefore, C2 is going to be equal to A2. And what's that? C2 and A2. Remember, A2 now is the angle between the tangent and the chord, is equal to C2, which is the angle in the alternate segment subtended by the chord. So in conclusion, we say that C2 is equal to A2 Therefore, we can write our concluding statement. BAT, that's the angle between the tangent and chord, is equal to C. Learners, once again, make sure that in a proof, you learn the construction, joint diameter AOK and chord CK. Learn the reasons used in the proof, angle in semicircle, tangent perpendicular to radius, and angles in the same segment. And if you do that, you will be able to prove the theorem. Learners, if you haven't subscribed, subscribe to JR Maths. Also, check out all the videos on jrmaths.com. You can like my Facebook page, Justin Lazarus Mathematics. And I'll catch you in the next video.